Hello friends, I am Dr. Rajesh, working as assistant professor in GMN college. I am back with my next video, and in this video we will discuss some problems of central orbit and we will find the law of force for those problems. And this video is one of the video among the chain of many videos on central orbit. So today's problem is given by this one. In this problem, we have to determine the law of force towards the pole under which the curve r raised to the power n is equal to a raised to the power n cosine theta. So we will start doing this problem, and the equation is given by, as we all know, okay, and we have to determine the law of force. In this case, we put again r is equal to 1 by u. This implies that one by un is equal to an cos n theta implies u raised to the power n an cos n theta is equal to 1. Since the power is n, therefore it is always divisible to take logarithmic on both sides. Now take the logarithmic on both sides. We have log u raised to the power n e raised to the power n cos n theta is equal to log 1 implies log u raised to the power n plus log e raised to the power n plus log cos n theta is equal to log 1. This implies that n log u plus n log a plus log cos n theta is equal to log 1. Now differentiating both sides, with respect to theta, we get n by u du d theta plus 0, because a is a constant quantity, plus 1 by cos n theta into minus sine n theta into n is equal to 0. This implies that nu du d theta is equal to minus n tan n theta is equal to 0. This implies that n by u du d theta is equal to n tan n theta. This will cancel out, implies 1 by u du d theta is equal to tan n theta, and this further implies that du d theta is equal to u tan n theta. Differentiating again with respect to, and you are going to name this equation as equation number 1, and you are going to name this equation as equation with respect to theta. We get d square u d theta square. Apply the product rule. U is as such secant square n theta into n plus tan n theta is now as such into du d theta. Now from equation number 2 we can write u secant square n theta into n plus tan n theta into u tan n theta, using equation number 2 where du d theta is equal to u tan n theta. We have put it over here. So this will be u secant square n theta into n plus u tan square n theta. We know that differential equation of central orbit in polar form is given by u plus d square u d theta square is equal to f by h square u square, named as equation number 3. Now substitute the values of d square u by d theta square from equation number 3. We get u secant square n theta into n plus u tan square n theta is equal to f by h square u square. Now collecting the first and third term, we get u is common, 1 plus tan square n theta plus u secant square n theta into n is equal to f by h square u square. This implies that u secant square n theta plus nu secant square n theta is equal to f by h square u square. This further implies that u is common, secant square n theta is common, and inside we are left with 1 plus n is equal to f by h square u square. This implies that u 1 plus n divided by cos square n theta is equal to f by h square u square. By equation 1, we have un an cos n theta is equal to 1. So cos n theta is equal to 1 by un an. Now substituting this value over here, we get u 1 plus n 1 by un an whole square is equal to f h square u square, and you write by 1. Now this implies that u dot u 2n a 2n 1 plus n is equal to f h square u square. This implies that u, this 1, this is 2n, so this will be 2n plus 1 a 2n 1 plus n into h square u square is equal to f, implies f is equal to a raised to the power 2n 1 plus n h square u raised to the power 2n plus 3, because this is 2n plus 1 and this is 2, so it will be 2n plus 3, and this a is constant, 1 plus n is constant, h is constant, so this whole is written as a constant lambda. This implies that f is equal to lambda u raised to the power 2n plus 3. This is lambda r raised to the power 2n plus 3, where lambda is equal to a raised to the power 2n 1 plus n into h square is a constant, and we know u is equal to 1 by r. This implies that f is inversely proportional to r raised to the power 2n plus 3. So this is the law of force, that f varies inversely as r raised to the power 2n plus 3. So this is the law of the force. Now next case is, we have to, if we take n is equal to 1 by 2 in the given equation, we get r raised to the power 1 by 2 is equal to a raised to the power 1 by 2 and cos 1 by 2 theta, because the given equation was Rn is equal to An cos n theta. This implies that squaring both sides, r is equal to a cos square theta by 2, which is further equal to a 1 plus cos theta upon 2. This is further equal to a dash 1 plus cos theta r, where a dash is equal to a by 2, which is equation of cardioid. This is the equation of the cardioid. So when we have taken n is equal to 1 by 2, the given equation is representing the cardioid, and we also have to find the law of force for that particular value. Now substituting, now say this equation is equation number a. Now substituting n is equal to 1 by 2 in equation number a, we get f is equal to lambda r raised to the power 2 1 by 2 plus 3 lambda r 1 plus 3 lambda r 4, implies f is varying inversely proportional to r raised to the power 4 when it is representing the coordinate. So this was the problem. Okay, now I will again discuss the problem. In this problem we were given the equation and we have to find the law of the force. That we have done through that particular equation a, and then we have substituted n is equal to 1 by 2. Then we saw that this equation is representing the cardioid. This is the cardioid and this is the law of the force for general equation, and this is the law of the equation of the cardioid, and this equation is obtained when we have replaced n is equal to 1 by 2 in the given equation, and for that the law of the force is f is varying inversely proportional to r raised to the power 4, where r is the distance from the pole, it is a radius vector. So this is the problem. Now next we will be doing the another problem in the next video, which will be with you very soon. So in this video we have discussed an important problem, and this problem is very important from the examination point of view. Very soon I will be with you my next video, and if you have liked the video, please like, subscribe, share and comment. Your comment in the comment section are very valuable and are appreciated always, and I would also request to share with the other students also in the different parts of the Haryana and different colleges, so that the maximum student in this current time are benefited. So this was all I have for you from this lecture, and I will be with you very soon with my next lecture and taking some more problem on to determine the law of the force. Till then, stay at home, stay safe and stay healthy. This is Dr. Rajesh saying you goodbye. Keep studying and keep working hard. Thank you very much. This is Dr. Rajesh saying you goodbye.